All right, calculus, welcome to the second video here. This is basically 3-3, 3-4 sections that is for your at-home notes here. So derivative of trig functions, we should have written these down. You need to definitely know that one, that one, that one, and that one by heart. Okay, you're going to see there's a bunch. If I ever ask you what's the derivative of cosecant, you can say, all right, what's the derivative of 1 over sine? Do quotient rule. Same thing with cotangent, cosine over sine, do quotient rule, and so forth. If you want to memorize all those, that's fine. But sine, cosine, tangent, and secant, I'll give you a lot of those questions. All right, so example 1 here, differentiate. Again, all these examples we didn't do in class. Okay, so this is new notes for everybody. Here we got the product rule. So derivative of the first would be 2x times the second plus the first x squared times the derivative of the second, cosine x, and that is it. Okay, so g of theta is equal to that. What is the derivative? Oh, I also wrote, oh, this is on the next one. Okay. So yeah, this would be the product rule. First function, seconds. Okay, so derivative of the first times the second plus the first times the derivative of second. Derivative of tangent theta is secant squared theta minus 1. And so you could rewrite 1 plus tangent squared is secant squared theta. So if you subtract 1, that's like saying tangent squared. So if you wanted to write that as tangent squared, you would be correct as well. All right, example 3, f of theta is sine theta over 1 plus cosine theta. So classic quotient rule, low, d high, derivative of sine is cosine minus high derivative of low, 1 plus cosine, that derivative would be negative sine, distributes cosine squared plus, cosine plus cosine squared plus sine squared, ding, ding, ding. Bells and whistles should go off in your head. Cosine squared plus sine squared, or sine squared plus cosine squared is 1. So that is cosine plus 1, or 1 plus cosine, which is going to give you 1 over 1 plus cosine theta. So you do need to know some trig. Example 4, if f of theta is equal to secant theta, find f double prime of pi fourths. All right, so the first derivative is easy. It's just secant theta tan theta. Second derivative has us utilize the product rule. Derivative of the first is another secant theta tan theta times the second plus the first times derivative of the second, which is secant squared theta. So my second derivative is this, secant times tangent squared theta plus secant cubed theta. So f double prime, my second derivative evaluated at pi over 4. So secant is the reciprocal of cosine. Cosine of pi fourths is root 2 over 2. So secant would be 2 over root 2. And 2 over root 2. Multiply top and bottom by root 2. It's root 2. 2 divided by root 2 is root 2. A lot of your calculators can just handle that. Then tangent of pi fourths is 1. We definitely need to know that. So if you square 1, you still get 1. Then I'm going to take that 2 over root 2 and cube it. So again, if 2 over root 2 is root 2, raise it to the third power means I square it, and then I multiply it by root 2. So it's going to be 2 root 2. And then finally, root 2 plus 2 root 2 is 3 root 2. I didn't have a lot of room there, so I apologize. That is an interesting one. So some of these are going to be a little bit on the more challenging side because you might have stuck to some easier ones last week when we were first learning it. Differentiate cotangent theta over e to the theta. So be honest with yourself. If you don't know what cotangent is, then you should rewrite it like this. 1 over tangent theta times e to the theta. Or I guess you could write it as cosine over sine. I don't know if that helps you out any. Because if you have a constant up top, then the derivative of high is 0. That's good. So low d high minus, I only have to worry about this, minus high, which is 1, and then d low. So you're going to have to use the product rule here within the quotient rule. Derivative of the first function is secant squared times the second plus the first times derivative of the second. All right, so what I did is I factored out e to the theta, put it with the -1. They both have e to the theta there. Factored out, you're left with secant squared plus tangent. All right. Negative e to the theta over 2 e to the theta. And e to the theta would cancel. And I just moved the negative sign through. Okay, so again, that if you do know the derivative of the top, so our answers could be the same but look a little bit different. Derivative of cotangent is negative cosecant squared. So again, you can know that, remember that if you want. Oh man, what are we going to do on 6? Do we have 3 straight functions? Well, we're going to look, that is the first, and that's going to be the second function, okay? So, product rule, derivative of the first times the second, that was easy enough, plus the first. Now, when I take the derivative of the second, I'm going to need the product rule again. So looking at that, I would take the derivative of that first part, negative sign, times the second, plus the first times derivative of the second. Okay. Now, what I did here is I flipped it. You don't have sine squared plus cosine squared, but you do have cosine squared minus sine squared. And, folks, that is cosine of 2 theta. So I bet a book would have that. All right. Or, you know, this is another answer, too, if you didn't know that was cosine 2 theta. Notice how this is pretty simple, though. Okay. If you didn't call that cosine 2 theta, this is how it would distribute out as well. Example 7, y equals 2 secant x minus cosecant x, which again, if you don't, what's the derivative of cosecant x? Might be hard to remember that one. So I just wrote it as 1 over sine. Okay, so I took the derivative of this function, which is easy, 2 secant x tan x, minus, so for the second function, I'm doing the quotient rule here. Again, if you know it's that, then great. If you don't, then you're going to have to do the quotient rule. Low, d high, which is 0, minus high, derivative of low is cosine, all over low squared. That is, oh, be careful here. The negative times, you know, a negative subtract a negative, there's a positive, so I'm going to boo-boo. You have cosine over sine squared, which is sine times sine, and that's how we get, you know, because if I ask you for something, the derivative of, you know, negative cosecant, and it has a relatively pleasant derivative there, we're going to have to simplify this in a different fashion, okay? So cosine over sine is cotangent, and then you have 1 over sine, and that's the cosecant part. If f of theta is theta sine theta, then find f, the first derivative and the second derivative. Find the first derivative and the second derivative. All right, so this is product rule. Derivative of the first, which is just 1 times the second plus the first, times the derivative of the second, perfect. Then the second derivative, I just take the derivative of sine, which is cosine plus, I do the product rule again, derivative of the first times the second, plus the first times derivative of the second. Cosine plus cosine is 2 cosine, minus theta sine theta. Not too bad there. I can pause this whenever you need to. Number 9, find the equation of the tangent line to the curve at the given point. So your curve is y equals cosine x minus sine x. And you want to find the equation of the tangent line to that curve at pi comma -1. So take the derivative. Well, that's just negative sine minus cosine. That's pretty easy. Plug pi in. So negative sine of pi minus cosine pi. That's 0. Minus, I don't know why I put the -1 there, but Cosine of pi is a -1. To subtract a -1 is to add 1, so the slope's 1. So y minus the y value, which is y plus 1, is equal to the slope 1 times x minus pi. You can distribute that if you want, but again, point slope form is perfect. All right, here on 10, same question as number 9. You have y equals e to the x times cosine x. Find that derivative product rule, which is derivative of the first function times the second, plus the first times derivative of the second, which is negative sign. Factor out, just factor out e to the x. That might help you out. Factor out e to the x, you're left with cosine x minus sine x. Plug 0 in for x, e to the first times cosine 0 minus sine 0. E to the 0 is 1. Cosine 0 is 1. We got another slope of 1. You can leave your answer in that form or that form. Differentiate x sine x divided by 1 plus x. So we got the quotient rule. And within the quotient rule, we're going to use the product rule as well with that numerator. So low derivative of high, d high, involves the quotient rule. Derivative of the first times the second plus the first times derivative of the second. That is all d high plus high, which is x sine x. D low, derivative of 1 plus x is 1. All over the square of what's below. Oh, man. So this times this, 2 terms times 2 terms. When you FOIL it, you get 4 terms. 1, 2, 3, 4 terms plus x sine x. So you have 2 of the x sine x's there. So I simplified it to be this. All right, f prime of x is that. And we're rolling. 2 more pages here. So note this as well. This is something we'll pick up on. Again, I think it's in your second homework. You got a few taking the derivative of like 2 to the x, 3 to the x. So note the derivative of e to the x is e to the x. The derivative of natural log is 1 over x. Again, going to the chain rule, the derivative of e to the u is e to the u times du dx. The derivative of natural log u is 1 over u times du dx. All right. Then the derivative of b to the x, or sometimes you'll see a to the x, a being and b being a constant, so like 2 to the x and whatnot, is b to that exponent times natural log b. So the derivative of 2 to the x would be 2 to the x natural log 2. Gonna have to remember that one. The power rule combined with the chain rule, that's pretty much, we're using this a bunch. So derivative of x, you're like, but that's u to the n. Again, we describe this function u as in terms of x. So we bring down the power, write u. Okay, we're taking the derivative of some u, which is in terms of x, bring down the power, so n, u to the n minus 1. Then I take the derivative of u with respect to x. That's what we've been doing. So you can write this in an alternative fashion as the derivative with respect to x of g to the x to the n power is bring down the power, g of x times n minus 1 times the derivative of g to the x. Both are the same thing, but I think using that u is helpful. So number 1 here, differentiate e to the secant 3 theta. We got the chain rule a few times. So we're going to think of this as e to the u, and the game plan would be the derivative of e to the u is e to the u times the derivative of u with respect to x. So that's what we're doing. So f prime of theta is e to the u times the derivative of u with respect to, in this case, theta. Should have put a theta there. So the derivative of secant 3 theta is secant 3 theta tan 3 theta. Again, when we have the derivative of secant x is secant x tan x, that x is whatever the angle is. Here it's 3 theta. All right. Now notice, when I take the derivative of secant theta, it's secant 3 theta, tangent 3 theta. But then I got to take the derivative of 3 theta, which is 3. Remember, everything, you're taking the derivative of theta here. That's the variable you're differentiating. Everything with theta has got to be involved with theta has to have its derivative taken. Okay? So we're going to rewrite it as such. On to f of x is 4 times tangent of u. 4 times tangent of u, and u is 2x squared. So 4 tangent u, the derivative of that would be 4 secant squared u times du dx. And that's what we're going to do here. So f prime of x is 4 secant squared. That's my u. Then I take the derivative of u, which is 4x. 4x times 4 is 16x. There we go. Let's talk about example 3 here. Y equals cosine of 3 sine theta. So that's your u, 3 sine theta. So the derivative of cosine u would be negative sine u du d theta. That's what I'm going to do here. So it's kind of like that first one. So y prime is the derivative of cosine, negative sine u times the derivative of u. My derivative of sine 3 theta would be cosine 3 theta times the derivative of 3 theta, which is 3. We'll practice some more of those. All right. And the last page here. More with the chain rule. Ooh, we don't want that. F of theta is tangent squared of n theta. Again, n is just a constant here. So you want to write this as tangent n theta squared. So the derivative of, that's my u, of u squared would be 2u du d theta. So the derivative of u squared, again, is 2u du d theta. So 2 times u, 1 power less. Now I take the derivative of this u with respect to theta. Derivative of tangent u would be secant squared, what my u is, and then I got to take the derivative of this with respect to theta, and that is n. All right, and I can combine it to be such. Just put the n there with the 2. Oh, man, number 5. Look at that. Well, e to the x is just u. So if I take the derivative of e to the u, it's just e to the u du dx. Okay, well, we can do that. So y prime would be e to the u times the derivative of u. And derivative of e to the x is e to the x. So e to the e to the x times e to the x, believe it or not, you have the same base. So you add the exponents. So it'd be e to the x plus 1. Oh, man. All right, let's talk about a more pleasant one. Cosine squared theta, so you're going to rewrite it as cosine theta squared. So this is honestly just u squared. The derivative of u squared would be 2u times du d theta. All right. So the derivative of cosine theta squared would be 2 cosine theta times the derivative of cosine theta, which is that, or brownie points for knowing trig at negative 2 sine 2 theta. Number 7, what's the derivative of cosine of your u there? Again, derivative of cosine u would be negative sine u du d theta. So negative sine theta squared times the derivative of theta squared, which is 2 theta. Bam. And the very last one here, I want the derivative of x squared times e to the negative 1 over x. This is another way to write it. Product rule, derivative of the first times the second. Derivative of the first times the second plus the first. When I go take the derivative of e to the u, it's going to be e to the u times the derivative of u. And the derivative of that would be negative 1x to the negative second. I'm going to rewrite that. The x to the seconds cancel. I can factor out the e to the negative 1 over x if I want, and that's an alternative answer there. And that is it, folks. You got those 2 videos of notes, and then I'm going to make a video with some homework help, and we should be good to go. That is Yak Math Videos signing out.